Hey brothers and sisters, Dominic Lucero, the instructor here for 549. Today I wanted to continue on with our discussion about trigonometry and field applications. So there's this term that we hear a lot to help us remember trigonomic functions, and that is SOHCAHTOA. So I want to give just a brief explanation of SOHCAHTOA, and we're going to actually pick it up a little bit backwards. We're going to start on TOA, and we'll work our way back. So, as you see, SO, which is S-O-H, CA, which is C-A-H, and TOA, which is T-O-A. What does that even mean, and why is that applicable to us? So really what that stands for is sine is equal to the opposite over the hypotenuse. Cosine is equal to adjacent over the hypotenuse. And TOA is tangent is equal to the opposite over the adjacent. And the reason why we're going to start with TOA today is because in my experience, that's typically our fallback a lot of times. That's the trigonomic function that seems to make the most sense for Boilermakers out in field applications. Now, whether it's rigging or whether it's layout or whether it's fabrication, it always seems to come back to TOA. And I think it's the easiest to understand and the easiest for us to use. So we got things like opposite, adjacent, hypotenuse. What does that even mean? So right here, as you can see on this triangle, there's different sides to a triangle, and each one has its own name. So the bottom is called adjacent because the bottom plane is adjacent to this angle right here. And there's a funny little symbol that we use to represent angles in trigonometry, and it's a little circle with a little curly Q, and that's called theta. And all that means is where there's an angle supposed to be in here. If it was algebra, it would be X or Y or what have you. So the base off of the angle is the adjacent. And these have names, so we have proper places to be able to pull dimensions off of and figure out our angles or figure out our legs. Over on this side, away from the angle, is the opposite side. And it's because it is opposite of that angle. Fairly simple. And then the longest side of the triangle is always known as the hypotenuse. So that's really where we're getting all these different terms from. So tangent is a nice easy way to say the ratio of something. So the ratio for a certain angle is going to be equal to the opposite dividing the adjacent. So what does that really look like, and what do we mean by that? Like I had said in the video before, an important way to look at trigonometry is to look at it in essence as a measurement of ratios. So we talked about the right angle, the right triangle, 45-degree triangle. And we had talked about how each leg on a 45-degree right triangle is going to be 1 to 1. If I had a framing square and I was trying to lay out a 45-degree angle, and it was supposed to be 10 inches on the base, working up the side of that framing square, if I go 10 inches and I connect those two in between, it will automatically make a 45-degree angle off the 90. So really what we're trying to do is we're trying to say for every angle, what is that ratio going to be? Because on the 45 right triangle, it's for every 1 inch over, it goes 1 inch up. Easy money. That's pretty easy to figure out. But what if it's not something so simple? What if it's not a right triangle with 45 degrees? Oftentimes out in the field, we'll come across different angles. It's not always so easy to come across 45, although it does happen. So what I have right here is I have a triangle, and we don't know what the angle is. And that's what we need to find out. We need to find out what this angle is right here. But the cool thing about triangles is if you have two parts of the puzzle, you can figure out the whole entire thing. So that's what we're going to try to do today. So as we can see, the opposite goes up 17. Might be feet, might be 17 inches. We're just going to stick with 17 for the example. And we can see that the base is 25 long. We'll go with inches. It's 25 inches long, 17 inches up. Now, like I said, every angle has a ratio to it. So for every 1 inch over, it's going to come so far up. And that's really what we got to find here. So we can pull out our calculators for this. I'm not a big fan of the trigonomic functions chart. It's not that they're impossible to use, but on your calculators on your phone, they have those already in them. So you can pull them up anytime. So what we're going to do is we're going to divide 17 by 25. And for anybody who's new to this, I know that might seem strange that we're going to divide a smaller number by a bigger number. But if you look at it, if we know that a 1-to-1 ratio is from a 45-degree angle, so we know that this isn't 1-to-1. We see that this only comes up 17 inches high, while this comes out 25 inches long. So we automatically know right off the bat that this angle is going to be less than 45 degrees. So we pull out our calculators and we divide 17 divided by 25. And you should end up with less than a whole number. If you have greater than a whole number, then you have to reverse them and divide them the other way. So the number we get out of it is 0.68. So what does that even mean? What does 0.68 have to do with anything? Does that mean this angle is 0.68? No. So what 0.68 means is that's the ratio of it. You could express it in several different ways. We could say that the ratio of the bottom base to the side coming up is 1 to 0.68. Or what we could say is for every 1 inch over on the base we go, this is going to come up 0.68 inches. Or roughly, we have 5/8 is 0.625, so 11/16 roughly is what that would be coming up for every inch over, which is a very easy way to be able to do layout of certain angles. We could also say that this leg right here is 68% of this leg right there. But how's that going to get us anywhere? Because we need to find out what this angle is. So typically, this is where you would refer to your trigonomic functions chart. And you would want to find what angle equals 0.68. And you would have to flip through all these pages. You want to find the tangent of that. And it could be time consuming. Not only that, I don't know about you guys, believe it or not, I don't keep a trigonomic functions chart underneath my hard hat, which surprises a lot of people. So we have 0.68. And on every calculator, if you're in degrees, which is really important, you want to make sure you're not in rad. Rad is the metric form of degrees. So we're going to make sure that we have DEG is the function on our calculator. And there's a really cool, if you look at it, there's a function on there that says inverse. And essentially what inverse does is if we punch in this 68% tangent and we want to find out what angle it is, it's going to spit it out for us. It essentially does exactly what that trigonomic functions chart does in the back of your first year books. It crunches it down and it spits it right out for you. So I'm going to hit INV on my calculator. And now I see a -1 next to the trigonomic functions. So now I can hit the inverse tangent of 0.68 gives me 34.21. So we would say that theta, or tangent, is equal to 34.21 degrees. So how do we know? How do we know that this right here is actually 34 degrees? Well, we could check our math. We could do the whole thing backwards. So another useful function for this, and in my experience out in the field, this is typically how I'm going to be using tangent. I'm going to be using it in this capacity right here, where I already have an angle, and I need to find out what the length of something is. So TOA works both ways. we can use it as almost an algebra problem. Because if we know that opposite divided by the opposite divided by the adjacent is 0.68, if we were missing one leg, if we were missing the dimension on 17, let's say we knew we had a base that was 25 inches, 2 foot 1 inch, what have you, and if we wanted to make a 34.21 degree up or out, how far up would we have to come to actually have that dimension be accomplished? So we're going to erase this 17 right here, and we're going to pretend it doesn't exist, and we're going to say that we know that this angle is 34.21. And now the question is, what is the length of this side? So what we can do to figure that out, if we have to divide the opposite by the adjacent, the other way to do that, if we were going to switch it around, is we would have to multiply it. We'd have to multiply the tangent of 34.21, which would give us 0.68. You multiply that by 25. And I'll explain that a little bit better. So, go ahead and pull out your calculators and follow along. So we want to make sure, once again, that we're in rad, and we want to make sure that we take the inverse off. We want to make sure that there's no negative sign next to tangent, sine, and cosine. Okay, so once that's off, what we want to do is we want to hit tangent, or tan, and we want to punch in 34.21. And on my calculator, give me 0.679, 0.68. So once again, what that's saying is that's our ratio. So the tangent of 34.21 equals 0.68. Once again, for every 1 inch over on that bottom, it's going to come up 0.68 inch. So now that we have the tangent of that angle, or the ratio of that angle, which is really what I want to get across, sine, cosine, tangent, these are just fancy words to say what is the ratio of that degree if we're looking at it from this angle. So now that we have our ratio, 0.68, I'm going to multiply that by the base, because what I did before is I divided it. So the opposite of that would be to multiply it. So that times 25, and look at that. It gives me a number of 16.99, also known as 17. That's a very quick introduction to how useful tangent can be for us on the job site. And I don't want this video to be too long, but before I wrap it up, how are we supposed to actually do that, right? How are we going to do these kind of things while we're out there in the field? It's very simple. Let's say we have a slope coming up on a Hersig, perhaps, right? Those walls are sloped up just off of the combustion turbine generator, and it goes straight up before it hits the first layer of tubes, or the first harp of tubes. So we need to make a patch in there, and we need to cut at a very specific angle. Let's just throw a number out there, 54 degrees. So if I already have the bottom of my plate I know I need to cut out, because I need to cut this triangle out to fit it in there, and it has to be right. It has to be airtight seal. I got to make sure that you can get a good weld on that. The base of my triangle is, let's just say, for example, 16 inches. So I would take my combination, or I would take my framing square on a piece of sheet metal or whatever it is we're going to be fabricating this out of. And I'm going to draw a 16-inch line, maybe mark it off on the side of that piece of steel. Okay. So now I have that, but I have to figure out how high up I have to go in order to be able to make a 54-degree angle. So we're looking for 54 degrees. And we know that this is 16 inches. So if I make a line straight up and I connect that line to this right here, that'll give me 54 degrees. So once again, we're going to go to our tangent function because we have our degrees, we have our base. The last number we're looking for is the opposite. So instead of dividing these, we can just simply multiply them and find the missing answer. Algebra. Okay, I pick up my calculator and I hit tan, or tangent, of 54 degrees, which again, what's the ratio of 54 degrees is what we're really looking for. The number we get there is 1.37. Now remember, I said a 45-degree angle has a 1-to-1 ratio. Anything below 45 degrees is not going to be a complete number. It's going to be point something. Anything above 45 degrees is going to give me 1 point something. So the number we get out is 1.37. So the tangent of 54 equals 1.37. And once again, it's all about perspective. That's what makes trigonometry so easy. When you see that, really what we're saying is if you have a 54-degree angle, for every 1 inch over on the bottom, it's going to come up 1.37 inches, or just about 1 3/8 inch. That's the ratio. Or we could say that this vertical leg right here is going to be 137% of the bottom leg. That's all we're saying. So I have my ratio, and now all I have to do is multiply that by the base. So that times 16 gives me 22.00 or 0.02. So 22 thousandths, 22 inches and 22 thousandths, which we're going to stick with the 22 inches. So if I just take my framing square and I hold it back on the base right here to get it square, and I come up 22 inches right there, draw a line. Now, there's my 22-inch mark right there. If I connect this spot right here with that spot right there, it's going to give me exactly 54 degrees. So let's try it out and see. Got to grab a straight edge, tie those two in. Okay. We cross those two. And we'll take my oversized protractor and we'll double check our work. So I'm going to put the center spot on the vertex. Make sure I line it up with 180 degrees. And if you look right there, we hit it dead nuts. Actually, it's about 54 and a half, which isn't too bad for using a piece of chalk. Piece of chalk that's roughly 1/4 inch in diameter. So that's a lot of slop that it gives you in there. And yet we were still accurate within 1/2 a degree. So it's not very difficult at all to get very precise angles out there in the field for fabrication. And if we were fitting this up for going up the slope of a Hersig and just replacing a piece of skin casing, it would sit right in there just perfectly. So any other questions that you have about trigonometry, please don't ever hesitate. I promise you it's really not as difficult as it sounds. Sometimes a good substitute for the word trigonometry is Jobsite math. It doesn't sound as daunting. So please stop by the training center at any time. I'm happy to sit down with you, and we'll make sure you get the education you deserve. Thank you.